Good day, everyone. And once again, your favorite uncle is back. And welcome again to our YouTube channel. Thank you for, becoming a subscriber. Hey, and if you haven't subscribed, please just click on that subscribe button. And of course, you can also join in as a member, right? Because our memberships are now live. You can click on join and become one of the members to enjoy valuable perks that we have, joining our WhatsApp group, and of course joining in on those live sessions that we do on every Thursday at 6 o'clock. So today we are looking at electrostatics. So let's get right into our question. Right, so we've got a charged sphere M, which is suspended from a ceiling by a light inextensible insulated string. They say another charged sphere N of mass 2.04 times 10 exponent negative 3 kilograms and carrying a charge of, okay, I won't be calling out those numbers, you can see them, right? Hang stationary vertically below the sphere, okay, which is sphere M, and the centers of the spheres are 0.3 meters apart as shown in the diagram below. All right, now let's get right into the question. So they say to us, we should state Coulomb's law, right? So remember, Coulomb's law simply states that the electrostatic force between 2-point charges is directly proportional to the product of their charges and inversely proportional to the square of their distance apart, right? We don't need to mention from their centers in that case because we're dealing with point charges. All right, 7.2. Moving right along, we're going to be really quick about this. State whether the charge on sphere M is positive or negative. Now, I want you to think about it, ladies and gents. So you've got sphere N, which is somewhat suspended, or rather it's actually suspended in the air, right? Now, already we know that there's a force of gravity that's acting on N, right? So we know that gravity is acting down there, right? But what is keeping N stationary? Well, it's because of the electrostatic force that it is actually feeling due to M, right? Because of M. So in this case, I'm just going to call this Fe, which is electrostatic force, right? So in order for this, now we were told that sphere N has a charge, a positive charge, right? So what does that mean? If this guy has a positive charge, it therefore means that N has to have a negative charge in order for it to be a force of attraction. Remember, if it had a positive charge, it would repel. So it means that both forces would actually be acting downwards. So I hope that makes sense. So we know that the force that is exerted by M on N is the force of attraction. And so as a result, it means that M is negatively charged. All right. So, okay, you can write that down if you want to. Okay, so we know it should definitely be negative. Okay, so let's look at 7.3. So 7.3, they say to us, draw a label free body diagram for sphere N, right? 2 marks out of 2 marks. So that's exactly what we had just done, right? So I'm going to have 2 forces there. One is the electrostatic force, or you can say the force of attraction. Okay. All right. Or you can say attraction force. Okay. And we also have gravitational force. And of course, those two, it's only 2 forces that we have. So let's just say gravitational force. Okay, so remember, because it's only those 2 forces and N is at equilibrium, therefore it means that those 2 forces have to be equal to one another. Okay, right, so it's out of 2 marks. So we're expecting that we should have 2 forces there. Right, now the next question, they say to us, calculate the magnitude of the charge on sphere M rather. So in this case, ladies and gents, we do know what the magnitude of what the mass is, right? So I'm just going to calculate that gravitational force there. So we're given a mass of 2.04 times 10 minus 3, right? So that's 2.04 times 10 minus 3 exponent negative 3, right? So times 9.8, right? So in this case, we'll say, well, that's 2.04 exponent negative 3 multiplied by 9.8. And we get that value there. Okay, so that's 0.019. So I can actually say 0.02, isn't it? So I'm just going to round it off there. I'm going to make it 0.02 newtons, right? So in this case, what does that mean, ladies and gents? It means that the net force, right, is equal to 0, first of all, right, between those two forces. So it means that the electrostatic force, or we can say the force between M and N, right, minus the force of gravity are equal to 0. So it means that those two forces must therefore be equal, right? So Nm is equals to the force of gravity, and so therefore it means that these are equal to 0.02 newtons, right? But now let's talk about the electrostatic force between M and N. We know that's going to be KQM Qn divided by r squared. So let's substitute. We already know the force between M and N. That's 0.02. So this is Coulomb's constant, 9 exponent times 10 to the exponent 9, right? Multiplied by the charge on M. That's what we're looking for. But the charge on N, we were given as 8.6, right? Times 10 minus 8. So we're looking for the charge of M. This one is 8.6 times 10 negative 8 divided by, they told us that the distance between them, if I remember correctly, that was 0.3, right? So in this case, that would be 0.3 apart, right? So now all we're going to do some mathematical gymnastics. Okay, I'm going to take that value, right? So this is over 1. So if we cross multiply, ladies and gents, that multiplied by the value of the force. So I'm not going to remove that value. I'm just going to multiply 0.3 squared to it. Okay, and I get, okay, so I get 0.017. Okay, so that's what I would have on the other side. Okay, so I'm doing this, okay, I'm just going to round it off to 0.18, right? I know there's some illegal stuff that I'm doing here, right? So in this case, on the right-hand side, remember, I've got 1 multiplied by that 9 exponent 9 times, that value for the charge, right? So let's find that out. So that's going to be 9 exponent 9 multiplied by 8.6 exponent negative 8. Okay, so I get that value there. Okay, 774. So I get 774 qm, right? And all I need to do is divide both sides by 774 to get my charge for qm, right? So that will give us, okay, so I'm going to just simply say 0.018 divide by 774, and I get that wonderful value over there. I think we can actually say that's 2 point, okay, so I'm trying to actually get it into scientific form there. Okay, so that's 2.3. Yeah, so that's 2.33 2.33, I think. Okay, so that's 2.33 times 10 to negative 6 coulombs. Of course, you probably have a much better calculator. I'm not too sure how to convert this to scientific, but nonetheless, it is what it is. In this case, that would be times 10 minus 6 coulombs. Now, we keep in mind, remember that the charge on M is negative, right? So let's not forget to put that sign there. Oh, well, they said magnitude, so in this case, it doesn't really matter. Okay, right, now, 7.5. They're asking us, how does the electrostatic force, rather, that the sphere M exerts on N compared to that exerted by sphere N on M with respect to magnitude. Now remember, in terms of magnitude, they are equal, right? So it means that the force that M exerts on N should be equal to the force that M, so they are equal, okay? And what about direction? They are opposite. Remember, according to Newton's second law, body A exerts a force on body B. Body B exerts an equal but opposite force. In this case, it's M and N, right? So they are opposite in nature. Right, and let's go on to the very last question. Okay, in fact, I think it would also be just prudent to, perhaps take that a little bit below there so that it's easier for us to actually work with it. Okay, so the last question. So they say to us, we've got point X is 0.1 meters vertically below the center of sphere N is shown below, right? So they say calculate the net electric field at X. Right, now please remember, ladies and gents, when you're dealing with electric field, all right, so what I'm going to do is I'm going to put the magnitude of the charge there. That's 2.33 times 10 negative 6 coulombs. And the charge on N, that was positive 8.6 times 10 minus 8 coulombs. Okay. I hope I calculated that correctly. If it's not, please let me know. Yeah, I think we are absolutely correct. Right, now, in this case, what we're going to do, remember, when it comes to electric field, in this case at point X, we always assume, or we actually model that point charge there as an imaginary positive point charge. So what's going to happen? It means that N is going to repel this charge, isn't it? So the field due to N, right, will be downwards, right, because N is repelling that imaginary positive charge, right? And then what about N? Because N is negative, right, it means that it would tend to attract that guy. So the field due to M, in this case, would therefore be upwards. So meaning, if we're looking for the net field, in this case, we're simply going to have a situation where we're going to take the difference of the two forces, right? So, two fields rather. So, I'm going to say, well, the field due to M, that's KQM over R squared. So that's going to be 9 times 10 to the exponent 9 multiplied by the charge of M, that's 2.33 times 10 negative 6 divided by, now what's the distance between that point there as well, with M, so that would be 0.4, isn't it? It's that entire distance there, so that would be 0.4 squared. Okay, so let's try and find that. So we said that's 9 exponent 9 multiplied by That's 2.33 exponent negative 6. Okay, and all of that divided by 0.4 squared. Okay, so I get a value of 2. Okay, let's just write it nicely. So that's going to be 131,062.5 newtons per coulomb. Sorry about that. So that's going to be newtons per coulomb, right? And when I look at En, that's going to be KQN over R squared. Now, please keep in mind, we said this one is going upwards, right? And what about En? In this case, that's going to be the same thing, multiplied by the charge of N, in this case, which was 8.6 rather, times 10 minus 8, divided by the distance between, yeah, they have passed it now. So the difference between, or the distance between those two would be 0.1. Can you see that? So in this case, it means that we will actually just write 0.1 squared there. Again, our calculation multiplied by 8.6 exponent negative 8, and we divide by 0.1 squared. Okay, so we get a value of 7,400 newtons per coulomb, right? And in this case, it's going downwards. Okay, now obviously, if you want to, you can choose a direction, right? Because I can see the one upwards is much bigger. I would say, well, in that case, I'll take upwards as positive. So therefore, it means to get the net field, it would be the field due to M, right? Because it's going up, it's going to be positive, minus the field due to N, right? So in this case, this is going to be 131,062. If you didn't want to have all of those numbers, you can actually just use scientific form, take 2 decimal places, right? So I'm going to take that number, going to subtract 131,062.5. Please don't be alarmed when it comes out as negative. That's because I've swapped the numbers around. So in this case, it would be 53,662.5 newtons per coulomb. So in which direction would it go? In this case, the net direction, it would be upwards, because the upwards direction obviously has got a bigger field, right? So it would be upwards. Okay, right. I hope that makes sense, ladies and gents. I hope you were able to understand. And please verify if our answers are correct. If they are not, please just notify me, obviously, on the on the comment section, and let me know if you understood. All right, please don't forget to join as members, right? For only 20 rands, you can join as a member, and of course you can benefit from all our live sessions and our Q&A sessions, ladies and gents. That's where I address all your questions as relating to mathematics and physical science. Otherwise, ladies and gents, don't forget to hit that subscribe button. I'll see you guys next time. Sharp, sharp.